Can anyone tell me what's odd or different about this picture? Here's a hint. Notice that there's a man flying down with an umbrella. In 1783, this man, Louis Sebastian, tried to figure out a safe way to escape a building in case of an emergency. He tested his theory by jumping off a 4-story building with just one umbrella. Luckily, he succeeded, and everyone got really excited. What he didn't know was that he had sparked a revolution that would lead to what we call the parachute. Today, we'll be talking about the physics of parachutes. To really understand why parachutes are so special, we'll begin by talking about how they work by looking at the daily forces this device needs to deal with. Then, we'll talk about its different applications and how parachutes are used every day. And finally, we'll discuss how we've improved its design from the very first one in the 1800s to what's being used now and in the future. If we drop this pebble and feather at the same time, which one do you think will hit the ground first? As you can see, the pebble hits the ground first. Does anyone know why that is? Mass and surface area have an effect on how fast an object reaches the ground. This equation is a general equation for the force exerted on an object based on its mass and acceleration. The greater the mass, the greater the force. In this situation, the pebble has a higher mass than the feather, so the force pulling the object towards the ground is greater. As we can see in this image, a man has just jumped from a 100-story building. What is the force being applied to this man called? That's right, it's gravity. What direction does gravity point in this image? Gravity points down. What's cool about this is that the man's acceleration as he's falling is only due to gravity. The acceleration stays constant at 9.81 meters per second squared. Since we know the value for the acceleration, we can replace the a in the general force equation with a g for gravitational acceleration. According to Newton's law of physics, free fall is any motion where gravity is the only force applied to it, just like in this case. Have you ever put your hand outside a car window? If you have, you would have realized that having your hand perpendicular to the ground, as seen in the photo, makes you feel a strong force pushing your arm back. It almost feels like the wind wants to take your hand away. However, if your hand is parallel to the ground or flat, you have more control and your hand isn't pushed back. This force is called air resistance, or drag force. It's a force that opposes the force of motion. Now, I'm going to do a demonstration with 2 pieces of paper. One is going to be crumpled, while the other one is unchanged. Which do you think will hit the ground first? Both pieces of paper have the same mass, but the crumpled paper still hits the ground first. This is due to the surface area. The crumpled paper has a much smaller surface area that will experience a drag force working against gravity. The flat piece of paper, on the other hand, has more surface area, so there's more drag force pushing against gravity and slowing down its acceleration, and making it look like it's floating down instead of just plummeting. This same concept applies with parachutes. The larger the parachute, the more surface area there is, and the more air resistance is created. As a result, when a parachute is first opened up, the people are pulled upward because of the sudden air resistance experienced. Then, as gravity factors in more, the people move downwards, with the parachute slowing them down so that they reach the ground at a safe speed. When an object falls through the air, it eventually reaches a constant speed known as its terminal velocity. This is usually very large while falling through the sky. This is the point where the object cannot accelerate anymore, and it is at its constant and maximum speed. The larger the air resistance, the smaller the terminal velocity, which is why parachutes are very important. Parachutes slow you down and allow you to return to the ground safely instead of just crashing. Parachutes need to be very large so that they have enough surface area to fully slow someone down to an ideal velocity. Now that we understand the physics and math behind the structure of a parachute, we can understand where and how they are being used in the world. Engineers always strive to be efficient and effective in all our work. We want to be able to adapt to the environment we live in and have a huge impact. During wars, we were able to use parachutes to safely evacuate troops from air balloons and aircrafts in emergency situations. After World War II, during the Berlin blockade, we used these parachutes to deliver food, clothing, and medicine over the wall. Besides the U.S. Armed Forces, NASA also uses parachutes every time they launch a shuttle into and out of space. It's important for them to be able to control a rocket's speed as it enters or leaves the Earth's gravitational force. In Apollo 11, which was the first mission to ever land 2 people on the moon, NASA equipped the rocket with more than 4 parachutes, 3 of which were the main pilot chutes, and 1 which was for emergency situations. Luckily, everything went smoothly. At over 10,000 feet in the air, the velocity of the spacecraft, which weighed 32,500 pounds, went from 175 miles per hour to 22 miles per hour, allowing it to land safely in the water. NASA is currently constructing a parachute to land a rover on Mars in 2020. This is a video of them testing one of the parachutes they recently designed. Even though they are testing the chute in a very different atmosphere, the shape of the parachute is still really similar to what we use on Earth. The functions are also the same, decreasing the rover's terminal velocity and allowing it to gently land on Mars with minimal damage. This is really important because the process of getting a rover into space is already extremely difficult. Another application for parachutes is exercise. Many runners attach a parachute to their back in order to create air resistance and make it more challenging to run. This helps them become stronger and faster runners, especially when that parachute is removed for competitions. Another sport that uses parachutes is drag racing. In a drag race, the cars are moving so rapidly that they are not able to slow themselves down quickly, which is why they need a parachute. It is able to decrease the car's terminal velocity or maximum speed, allowing it to come to a stop. Now that we know how parachutes are used, we'll take a look at the various designs parachutes have taken and what the future has in store for them. Parachutes have been around since the 15th century, and it is unclear who created the first parachute. Many believe Leonardo da Vinci created it. A model of his original design can be seen on the left. The shape of the parachute has evolved since then and no longer has a pyramid shape that was once believed to be beneficial. The wooden frame he used in his design wouldn't be able to withstand all the air resistance forces a parachute deals with. In 2000, a man tried to use a parachute modeled after Da Vinci's design, as seen in the picture on the right, and had a successful landing. However, he needed to tweak the design in order for it to work, as well as carry a backup parachute which is not very efficient. From there, we move to more circular designs, which are mostly used today because they are the safest and most effective. They create a lot of air resistance, which slows the person down immensely. The circular shape is able to take in more air molecules than other designs, and when it is released from the backpack, it can easily catch the air and open up without any issue. That is why skydivers typically use a parachute like this. Even though they are harder to steer, they are safer. As you might have noticed, the design has holes in the top of the parachute, which might seem counteractive, but to better understand why they're helpful, let's consider laundry hanging on a clothesline. When a gentle breeze hits the clothes, they billow or become curved at the center. However, when a large gust of wind comes, the clothes move erratically and they often become tangled or twisted. The same thing would happen to a parachute without the hole in the center. Parachutes have to take on a lot of wind at one time, and the hole at the top channels the air out in a controlled way. If the hole didn't exist, the parachute could become tangled, which would be very dangerous. This allows the parachute to be stable, which is a very important factor for parachutes. Another important factor is mobility. Parachute designs are changing even today. The military is currently trying to move from using circular parachutes, which they've been using for almost 50 years, to square ones. Circular parachutes have more air resistance, making them safer to use. However, for the military, mobility is a very important factor, so they are looking at designs that are a compromise between accurately landing on a target while still being safe. The future of aircraft safety may potentially be in the hands of parachutes. 10% of all small general aviation planes are equipped with a single chute that carries the plane in case of an emergency. This use is still debated for larger aircrafts because of how bulky the parachute would be and how much room it would take up, meaning less passengers would be able to board the plane. A commercial plane can weigh almost 400 times more than a small aircraft, so designing this would be a real challenge. But it could improve the safety of plane rides. As we have discussed throughout this presentation, the larger or heavier something is, the greater the surface area of the parachute for that object. So it is still unclear how such a parachute would be created for commercial airplanes, but engineers are constantly testing new ideas to make this become a reality. As you can see, engineers are involved in every aspect of the innovation of the parachute, from the design to prototyping and constructing it. Hopefully, you will be able to join these engineers in creating a more efficient and safer parachute for the future. Thank you for listening to our presentation. Does anyone have any questions? Now we'll be moving on to our fun, hands-on activity. You guys are going to build your own parachutes. Real engineers have to learn how to design and manufacture a device while under cost, time, and other restrictions. For this project, you will have 10 minutes to build a parachute using the list of supplies listed on the slide. As you can see, each material has a cost attached to it, and altogether, you cannot spend more than $70 on your parachute. Your chute must be able to hold a ping pong ball, since that will be the object we drop from a height. The goal is to design a parachute that takes the longest time to land, but does it accurately. Your ping pong ball should reach the target marked on the ground.
Hey, I'm Andrew. I'm an electrical engineering sophomore here at RPI, and today we'll be walking you through the physics of parachutes hands-on activity. So in this activity, you'll be creating a parachute using these materials and trying to deliver the cargo, the ping pong ball, from a certain height down onto a target. And so the certain height can be as you decide, but today we'll be using a stepladder. And so first, let's walk through the materials. First, we have a coffee filter, so a Ziploc bag, and a construction paper. These three materials are typically the parachute. And as you learn in your activity, that catches the air as it falls down to allow the parachute to fall slowly. Next thing that we have is a pipe cleaner, a bamboo skewer, and a string. You can use these as ever you want, but typically they're used to attach these parachute catcher onto the cargo, the ping pong ball. And then finally, you'll need to be able to attach the string to the parachute. And so we have tape, glue, and then finally we have scissors in case you wanted to cut up the construction paper or cut the bamboo sticks. So as engineers, one of the biggest things we need to do is be able to design, hypothesize, test, and then redesign. So typically we give students like a paper like this that has things like make hypothesis, list the materials, and then design your design. And so with this, students can make hypotheses. They can say, oh, a bigger area may allow the parachute to fall slowly, or they can say a heavier parachute will allow it to fall quickly. And then using that idea, they can think, okay, what materials do I want? Do I want to get the construction paper? Do I want to get a tape, etc.? And so with the materials, we also implement a budget in order to limit the resources that the students can have. So in the real world, engineers won't have unlimited resources. They're going to be constricted to a budget and a certain resources and limited activity. And so what we need to do is make sure you can't use as much resources as possible and that you can only buy certain things. So what we typically do is implement a $70 budget with materials shown here. And things like string, 1 foot of string will cost $10. This will allow the kids and students to use their creativity more given the restrictions. And so after we do the testing, we would want to redesign and re-implement to try to get a better and better design. So we'll be right back after designing the parachute to go forward. All right. Now we're back and we finished building our parachute now. And so what I used here was a coffee filter, some pieces of tape, 4 pieces of string, and then a pipe cleaner. In our budget, this is $70, so exactly the amount. And so what I'll do now is I'm going to hold it up here and drop it. So It was relatively accurate. It landed on the bullseye, which is great, but it fell kind of fast, and I think we can improve the accuracy. So when we go back and redesign this, something I might do is increase the area of this parachute, and I might increase the weight here so that it can pull it down more straight. And this is very important for engineers, so when they redesign their project, see what went well, what went wrong, and try to get the best product out there. So thank you so much. This is the hands-on activity for the Physics of Parachute, and thank you so much for watching.